All right. Can everybody see that?
White screen.
Yes.
White screen says pedal drive discussion.
Now we see it.
Yep, there it is.
All right, pedal drive discussion. Let me see here. All right. So just a brief overview about Jeff and I, or our relationship. We grew up together. We met in 6th grade. You know, many of you may have already heard this, but I lived about a mile away from Jeff. His parents and my parents got to be friends. We got together. His parents taught me, Jeff and his parents taught me how to sail. I took Jeff out backpacking, and ultimately my dad got into windsurfing, and so we taught Jeff how to windsurf at the time. We lived on a local reservoir, and so, or Jeff did, and we were about a mile away. So we went through college together, roomed together for a couple of years. We're best men for each other's weddings. We kind of went our separate ways for a while and reconnected in 2016 when Jeff came out, or asked us to come out, me and our other friends, to spend some time on Ruf Duck with them. And at that time, I think that was 2016, and you said something about Race to Alaska at that point. Is that right, Jeff?
Yeah, that was the big deal. You know, we were going to do, go ahead and sign up for R2AK, but of course, that was the first year it was canceled.
Yeah, so we spent, you know, I think, so 2019, let's see, we started in 2019, this is 22. So yeah, we spent about 3 years working on the pedal drive, talking it over, coming up with different ideas. I counted them up. It's like over 1,000 emails.
Are you?
Over 1,250 emails were sent back and forth, trying to sort out just all the choices which needed to be made. So, which was great, because we had a lot of fun doing that, and we had a lot of fun, I think, posting on Facebook and doing some other stuff too. So it was a great way to reconnect. So now the big disclaimer, which is I'm not a fluid dynamics guy. You know, we got people who know a lot more about boats than I do that are listening to this right now. My background is in engineering, kinematics and dynamics, were some past planning. So I did some stuff with robots, but that was years ago. And Jeff, just kind of out of the blue, when we finally decided to do Race to Alaska, I think he told one of my friends who's a veterinarian, you get to be the first aid guy. And another guy, which is a close friend, he said, you get to be the self-defense kind of thing. And then he turned to me and said, Mike, you get to make the pedal drive. And I'm like, what? It was crazy, because, I had no idea what I was doing.
He's the only engineer I knew on the team.
Yeah.
Logical choice.
Yeah, right.
Yeah,
Someone had to do it.
So, so when we started this, we went through several iterations, and we really didn't know what we were doing. And we started asking questions, and there were just so many questions. And, I've listed them out here. How many people were going to be on the pedal drive? How many pedal drives? I mean, that was kind of a question. I think at first we were talking about 2 pedal drives on the boat. And then we ultimately decided on a tandem bike, and it made no sense to have 4 people trying to pedal at the same time, because you just, the crew amount would be 4 people anyway. So, what shaft sizes are we going to need? What is the loading on these shafts? What kind of propulsion were we going to use? I mean, we looked at all sorts of stuff. Was it going to be propeller? Was it going to be Mirage drive? Was it surface piercing? We've seen paddle wheels. What's the most effective way to do that? If we choose a propeller, what pitch and diameter? The list just goes on and on, and we had no clue at the time. And of course, on top of all that, Jeff has an obsession with weight, which I think everybody listening to this probably does too. And so it was, you know, the thing is, from my point of view, being asked to do this, I had, you know, he would come to me again and again and talk about reducing weight. And I genuinely, the only thing in my mind was it's got to last 750 miles. And
How many of those emails were about weight? Did you
there
count
was-
those?
Yeah, I did not.
Over
Yeah.
half, probably.
Yeah, yeah.
Everybody's going to find out why. They're all going to agree with me here.
Yes, they
I
are.
know they will.
are. So in Jeff's defense, we're going to look at some of the stuff I sent him. Which here's one, which is the gimbal that we were originally that I sent out to him actually, and this was going to mount to his transom and hold basically the pedal drive in place. And I think, do you weighed this, Jeff? How much did it weigh?
I don't know.
Remember?
Over 10 pounds. It's designed to hold like an Isuzu diesel 3-cylinder thing. You know?
Yeah. Well, you know, we really hadn't figured out everything yet. And I sent this stuff out to Jeff. Unfortunately, he made modifications, which at the time worried me quite a bit, just because I didn't know that it would work. But he has pretty good judgment, so it worked out well. Here's another picture of our pedal drive, which is more or less where we ended up. This is version 2. And this is when I sent it out to him. And this is an example of some of the weight we're talking about, which is, you know, you can see I have a steel shaft running down, and of course Jeff ripped that off, and I think you had an old windsurfing mast or something that you stuck in there, if I recall. So, but then the drive shaft itself, which is a flexible drive, it weighs a lot, and it, you know, the list goes on.
Well, while they're working on that, I would just like to point out that, you know, this piece of, you know, low carbon steel shaft that Mike has in here still has the little skeg on it, even, because it was actually, you know, a piece out of these Taiwanese, you know, mud motors, you know, these things that they put a V8 engine on the end of and a little prop on the end. So yeah, it was like a 1/4 inch thick pipe. It was very, you know, schedule 80. I don't know.
It was heavy. Yeah.
It was the first thing to go. Yeah.
Yeah.
Well, what I'd like to ask a question, if you can hear me, and that now that you presented a shrouded propeller, what is it that inspired you to go with the shrouded fan, which is unlike anybody else?
So we'll get into that, but the short answer is it's a bit of a no-brainer. You know, when you start thinking about it, because you know, Kort nozzles are great for, you know, everything I'm reading. Let me put it that way. Everything I'm reading is Kort nozzles are great for low-speed applications, and this is exactly the situation we're looking at when we're trying to push, you know, Jeff's boat. And just about any boat, you're looking at like 3 or 4 knots of speed. So the question becomes, and we'll get into this in the next slide, is very soon. It becomes a question of efficiency, not a question of going faster. So it's a question of how can I squeeze out as much efficiency out of this system as I can, because you're only going to go so fast. So let me see if I can get in here real quick.
Mike had promised to me that it would give us the stamina of 20-year-olds. So I was thumbs up.
Yeah. I don't know. You know, I think I threw it out there, and Jeff's a pretty positive guy. So, I mean, just about everything I said, if it didn't weigh a lot, he generally went for. So, but these are some examples of, and I don't even know whose boats these are, but these are all examples of people who have entered Race to Alaska before, and we were looking at all these things in order to figure out what we thought we liked and what we didn't like. You know, there are things about this as I look at it that I like. It's very simple, very straightforward. I don't like the big chain. I don't like the chain going into the water, and I don't like it going around a small gear set. So there's a lot of friction involved in that. This is a kind of an elegant solution. But yeah, I mean, all of these things, I think this is Sail Like a Girl. Is that right?
Yeah, I think so.
I think it is. Pretty elegant setup there. Out of the way, location's great.
Just if I could just say one thing about Sail Like a Girls, they do have two different seat configurations there. So they don't have to be sitting and getting saddle sores the whole time. They can switch back and forth kind of between postures, which I think is a benefit of that layout.
Yeah, it's a really cool setup, and especially when you got so many people on the boat, you can keep those things cranking all the time. So putting two on the boat makes so much sense, and it's out of the way. But yeah, there's a lot there to like, I guess is what I would say. Yeah, another off the back for monohull. This one, the interesting thing I would say about it is if you look at the chain setup, they're transferring power a lot of times, and so you've got the pedals going through like a Mert pack gearbox, going to a chain, going to another. Oh, there's Russell Brown's. But yeah, and so there's so much happening here that there's going to be a lot of friction loss. This is probably the most elegant solution. You know, of course, Russell Brown. You know, you expect no less. We looked at Big Moderna quite a bit, or I did at least. I don't know. And in fact, we talked to, was it Lars, Jeff? I can't hear you. You're muted now.
His brother.
His brother Nels.
No. Oh wait, no, it was Lars. Yeah, no, it wasn't Nels. It was Lars. Yeah, you're right.
Yeah. And actually talked to him for a little bit about their system. And I like their setup. However, I don't like it strung across the cockpit like that. And there's a lot of chain that's being slung around. But we really liked this flexible drive shaft, and the way they did that, I think that's arguably better than what we have going as far as how elegant it got into the water. It's a nice setup. And of course, if we're talking about pedal drives, it's hard not to talk about Team Boogie Barge. These guys, I just have huge respect for. You know, they did Washington 360 and were way out in front with Bend Racing, I think. You know, I think until things just wore out. I think at that point in time, they had a tandem setup, just two on the boat. But
Two people pedaling in a
guys,
3-person team.
what's that?
Two people pedaling in a 3-person team. They would rotate
Was
through.
that what it was?
Yeah, for Washington 360. Mhm.
Okay. So, but it's interesting to look at this year just because I think they went all in. You know, they put 4 people on this thing and they tried to crank out as much power as they could. And they came in 4th place, which is pretty good. I think 2 years earlier they did, or 3 years earlier they did. I think they came in 6th place with a 2-man team at that point in time, a different boat as well. But the reality is they're beaten by some kayaks and I think a rower as well. And so, you know, if you start to look at the numbers, it really becomes apparent that when we start, I'm going to skip down here. Whoops, there we go. That if we're taking a look at the amount of power it takes, I won't bore you with a bunch of equations, but this is one that I thought was pretty important and that we ought to get kind of cleared up. So if you look down in the lower right, we have a power equation, and this is just for viscous drag. There's basically 2 different kinds of drag that are affecting the boats, the speeds we're operating in. There's this viscous drag, and then there's a form or pressure drag. And since we're not going to worry about wave drag, like when we talk about hull speed, because we're nowhere near hull speed, right? These boats are way too long for that. We're averaging right around 3 or 4 knots, something like that, typically. And so when we take a look at that kind of drag, which is the big influence for what we have, we see this equation and it's got velocity cubed. It's got this V cubed over there. And what that means is that in order for us to make the boat go twice as fast, we have to put in 8 times the power. So, you know, if the average person can do maybe 150, 175 watts, something like that on a bicycle. You put 2 people on a bike, you get 350. But if you take a look at our speed difference, at 175 watts, we're going 2.96 watts, something on that order. And then if you put another person on, you can increase it, but you're not going to get these huge leaps and bounds. And so even when they put 4 people on their boat, when Boogie Barge did that, it still wasn't enough to get them across the finish line. And I think ultimately they had enough drag in their boat that was inherent in the boat itself that caused that they just couldn't overcome. And so as a consequence, if they're ever going to win the race or improve their standing, I think that they need to probably change their boat because the drag is just too much compared to something like a kayak or a rowboat, a sculling boat.
Their hull form is a little fat, actually. It's not as long and skinny as, say, some of the rowing shells that they're competing against.
That's right, and they have 2 holes side by side. So I mean, it all adds up, absolutely. But like I said, I have huge respect for these guys. We have a list of information if you guys want it. We'll make it available to you as far as where we got some of this information. One of the people we got, of course, Narwhal. Thanks to Narwhal, Mark Dix. Thanks for the work you put in and the Bill put in. They gave us their pedal drive, the initial pedal drive, which you see a version of that we modified. Elizabeth Boyd is a person we talked to briefly. She had done the submarine races, which you see colleges compete in. And so she did some prop design for that. And she gave us some advice, which was basically that you want the largest diameter prop with the highest pitch, was her commentary. She said there are some caveats around that. And then we kind of lost touch with her and we never heard from her again. So we never found out what those caveats were. But I think the 2-bladed large diameter prop, which you see quite often, is what she was kind of echoing. And I would argue, and we'll talk about props in a little while, that you probably even need a higher pitch for some of these boats. Of course, Sailing Anarchy, Sheldon Brown Bicycling, the list goes on. So I won't go through them all. When we look at this power curve, I think the couple of myths to kind of put aside, everybody wants to compare pedal drives, how fast are you going? What's your gear ratio? All those kinds of things. And the reality is you can't really compare one boat to the other. If you took our pedal drive and you put it on a different boat, you get a totally different response. And I like a lot of the ideas, obviously, that we put into our drive, and I think some of those ideas should work well on other boats. But it's pretty hard to say our boat is faster than your boat, so we have a better pedal drive. It's just not the case.
I think I did say that though on the R2AK Racer forum. I haven't heard anybody call my bluff yet, but
yeah, I'm calling your bluff.
Yeah,
that's it's I think everybody, you go to these things and everybody has that competitive streak, and we're all looking at what ideas anybody else has come up with, and it's just not really a good idea because it's apples and oranges.
The empirical data though seems to show that we pass a lot of people under power.
That's because we're a bunch of beefy old guys, right? We just have the muscle power, but I don't know. Yeah, we did good. I think we should be proud of what we did. But yeah, like I said, you think Pesto, he had one guy, he had a prop off the back, he didn't have a duct, and he was moving pretty well, I thought.
We were
So,
faster than Pesto.
yeah, and we should be,
Yeah,
although
'cause-
he was lighter too.
Because it's
so.
just one person, yeah. I assume you're going to talk about the disadvantage of one person pedaling eventually, right?
I am, yeah, we'll get there. I'll try to blow through some of this stuff. We created 3 designs throughout the years, the 2 or 3 years we worked on it. Here's the first one. This is what Narwhal more or less gave us, and we modified it. It is we put a larger chainring. It's an 80-tooth chainring on the top. We put an internal geared hub on it. And then there's a chain drive that runs down the aluminum shaft to the prop, which you see sitting on the floor down there. And after we got completed with this project, and then COVID hit, and we were knocked out, we couldn't do anything with it. We really took a look at and kind of boiled down what was important to us. It was a great project because we learned so much from it. And honestly, the internal gear drive, it went out the window. There's just too much friction. And same thing for some of the chain going down the aluminum shaft. The things we learned was that friction is the enemy. Given that graph, we talked about power. You can't, everything on that graph is showing it has to do with just the boat. There's nothing about a pedal drive on this graph. It all has to do with the nature of the boat that you're on. So if I'm given these conditions where at 350 watts, if I'm dumping 350 watts into a boat, the question is, how can I make it go? I'm only going to get 3.68 knots out of it. That's it. So the question is, how can I most efficiently get to that point? And, how can I avoid all of the friction losses? And there's a lot of friction loss in this design. So here's another picture of it. And then a third. So once we completed it, we figured out some of the questions surrounding it. How are people to be positioned when we're pedaling? How is the pedaling motion going to be transferred efficiently? On down the line. We'll go through some of these. This was our solution for version 2. It was basically Jeff found a cheap tandem bike, and we strung it between the main hull and the float. And it worked great, honestly.
It's a steel frame, so it was a little heavy, but other than that.
How is pedaling motion going to be transferred to the shaft efficiently? One of the things we decided was that we wanted to take our pedaling motion and transfer it directly to the shaft that was going to rotate the prop. We did not want to screw around by running, from one set of gears to another. You're just going to have energy loss when you do that. So we go from a chain ring back here to this shaft setup, and this is the shaft that's going to be hooked to our flexible shaft directly, a direct drive straight to the prop. So as opposed to this, which I was talking about earlier, where you have all these different chains and gear transformations that are occurring, and it just eats you alive. We used cleats, bicycle cleats, to make sure that people had good contact, which I know this is probably not a fan on boats, but Jeff, I think they were worth it, weren't they?
Yeah, I mean, I was a little worried about it at first because I'd never used the clips, and I was a little afraid of people getting hung up on them and not be able to get off. But in reality, they're actually not very difficult to use. And they do allow you to get a lot more power simply because you have a more efficient rotational force, and you can pull up, with your foot as it comes around the upswing. So it's just easier to transmit more power.
We want, you see a lot of discussion about belts versus chains. We wanted chain, bike chain, because we wanted to be able to use gearing. It's more difficult to do that with a belt. So as a consequence, we went with chain. They do require maintenance, and yeah, in the races we've done, you actually feel like there's something on the prop, and it turns out that if you just go through and you do some maintenance on your bike and your chain, things will free up and get moving pretty well. What mechanisms are you going to use to transfer water down into the water? How are you going to transfer power down into the water? And that seems to be a common obstacle everybody tries to overcome. There's lots of different ideas. You could try to use a U-joint, although we shied away from that for a few different reasons. Some of which have to do with the vibrations that occur with U-joints. If you have things going up and down, it could be pretty odd oscillations in the powertrain. But ultimately, we went with the flexible shaft idea that Big Moderna had going, and you can see that echoed here in our design number 2. How is the propeller going to be stowed when it's not being used is a big question. This is a pretty elegant solution. I like this a lot. The idea of just raising these things up on poles on the back of your boat is pretty sweet, and then lowering it down when you need it. Sail Like a Girl, where they had theirs located, just pivoting it up from vertical to horizontal seems like a great solution. And of course, you could do something else, and this is ultimately what we did. Of all of the things in our design that we have, that I have an issue with right now, it has to do with getting this boom and duct up out of the water. I have some ideas to address that, but that's still the one thing that we haven't solved yet.
Yeah, the trick was really that when you get up to any kind of speed that you're going to want to start sailing at again, that Kort nozzle really wants to track. It has a certain angle of attack and it wants to stay there. So when you're trying to pull that thing up out of the water, it really wants to resubmerge. So there's quite a bit of force necessary to pop it up, above the surface of the water.
Yeah, we would literally, I don't want to say we would stop the boat, but we would have to slow the boat way down if we hit a gust of wind and all of a sudden the wind started picking up and we started sailing. You start doing 6 knots and you're trying to pull that thing up out of the water and you just can't. There's just no way. And so we end up slowing down and pointing up into the wind a little bit and then getting it up and moving again. So what is the best propeller to use? I've heard that there's some question about what prop to be used, and this is a standard prop that most people are using for Race to Alaska. They can get it from APC. CF1G, it's a 20-inch diameter prop, 18-inch pitch. This is a propeller I made, which was a folding prop. The idea, we were worried about having a freewheel on the back and not having the prop actually drive the pedals as this boat is moving forward. So a folding prop would have taken care of that. I came up with a couple designs. I don't think we ever used them because we ended up finding that we have a freewheel and it worked great. Here is a prop which has recently come out. I was on the APC site just sometime in the last week. And I was actually kind of surprised to see this. I think I may have seen it before, like 6 months ago, but they are now selling on the APC website for RC planes. They're actually selling propellers for kayaks as well. So this is a 14x17 kayak paddle or propeller, which, it's in the ballpark, and especially for like a single man setup, it might be a good option, is what I would say. I put this one in here. This is actually from the submarine races. This is what they designed. And it actually was a variable pitch prop. This is one blade of it. And, they had run simulations, and this is what they had come up with. And the thing I would point out with both the kayak prop and this prop is you look how thick it is towards the tip. And I think that was what kind of caught our eye. And so ultimately we ended up carving our own prop. And then if you take a look at that fact, that you have these different shaped props that are being used. And then you have people like Big Moderna, Sail Like a Girl, and Boogie Barge. Sail Like a Girl, the first few years, they did not change props, I don't think. But the last year that they entered in Washington 360, I am sure they had a different prop that they had made for the boat. So all of them ended up changing props. And I think ultimately, what you find is that there's great reasons to use the APC prop. It's easy, it's economical, it's relatively efficient, it's large diameter, proven to go to distance. It's done it plenty of times. However, I think that if you don't have a duct, if you take a look at how much slip is occurring, and what slip is with a propeller is, you guys may already know this, but if your prop is running at a certain speed, the pitch dictates that it should be going forward at a certain rate. And if the boat is not actually moving at that rate, but moving slower, that's called slip. And so all of these boats in these highly viscous, low speed settings, there's a huge amount of slip that's occurring. And so you have this prop, which is meant for air, meant for running at like 10,000 RPM, has an airfoil on it. Well, that foil, if there's that much slip is occurring, it doesn't have the appropriate angle of attack. And so as a consequence, it just throws a lot of questions into whether or not that prop is the best prop for the job. And so, ultimately, I think what we did is we said, let's try something different. And so this is the kind of data that you get off of a prop typically. I'd love to see something like this for water props, but you don't typically. So in a little while, I'll show you the picture of the prop that we ended up carving for version 3. But then there's a question about the Kort nozzle. Kort nozzle is great at making propellers more efficient at low speeds. So I think it's great at providing good power at low speeds as well. And basically they provide lift just in the nature of the shape itself, but then they also help to eliminate some of the vortices which are occurring off the tip of the prop. And so, yeah, I'm a firm believer that the Kort nozzle, for any of the larger boats that are trying to be pushed by human propulsion, the Kort nozzle is a great idea. I'm a big believer in it. I think if you start taking a look at some of the smaller boats, if I was Boogie Barge, I would not be putting a Kort nozzle on that boat. It makes no sense whatsoever. So here's ours. This is the manufacturing that we went through. Let's see, gear ratios. Everybody talks about gear ratios, and really what it amounts to is, I think what we found was a gear ratio around 5, which I think is typical, but it's likely that if you're not using the prop that we're using, or if you're on a different boat, you're going to have a different gear ratio. So and in fact, when we put our other prop on our boat, we did change our gear ratio slightly. This is a picture of our system, version 2. It's of course in Jeff's backyard. It shows a pretty good image of how it sat in the water.
That's version 1, Michael Hummels.
Well, version 1 was the one that we got from Narwhal. So
yeah. Okay, right. Yeah, first duck.
So but I don't know, Jeff, what did you like about this particular setup?
Well, I think this was just the first, this was our first attempt at getting everything mounted on the boat. And that's a little bit of a trick because, you're trying to hook it to existing points. I mean, there have been people who've done the race in the past who mentioned they just don't want to drill a bunch of holes in their boat, and I didn't want to really drill any more than I had to. And so you're trying to figure out how to get this attached and how to cantilever off the existing motor mount, and then to try and get that all to work out without putting some extreme bends in the shaft. So this was, this was just our first attempt at trying to get all the alignment.
Yeah, and I think the version 2, we got it done with Washington 360, which was a huge pedal fest. I mean, it was just a huge amount of pedaling. And we were relatively thrilled, even though at the very end our pedal drive broke. But I think that the boom nature that you're looking at right here worked very well, because it follows through the wave action extremely well. It keeps the prop in the water. It keeps us level in the water very well. Push the boat. The only time we would have an issue is if we were not making forward progress through the water. And if that happened, the boat, the boom would have a tendency to wander a little bit. But I think it can be addressed we ended up addressing it by tying some stays, tying some lines to it, and stabilizing it that way.
Yeah, once there was laminar flow, it tracked really well. But with no laminar flow, it didn't have any directional stability.
But that doesn't matter. 'cause
Rear view of it. What's that?
It doesn't matter, because if you have no laminar flow, that means you're not moving, right?
Just when you start up, right?
Well,
Oh, just-
it matters if you're going through Deception Pass. Let's put it that way.
Yeah,
You know?
or basically, if you're going into the wind and it's essentially kind of pushing you back a little bit, it would sink. It would either sink or it'd slew to the side, just because you didn't have enough forward speed to keep it tracking. So it's once you're going, it was fine. And so, like Mike said, we just rigged some stays, 2 side stays and a topping lift on it. That seemed to work just fine. I think in the end, Mike, didn't we mostly just even use the topping lift?
Yeah, I think so. Yeah, just as long as we keep it up and not pitching down, it worked fairly well.
So would the shaft flex as it went down and then approached the propeller?
You can see it there.
Yeah, when you say would it flex, you mean as it turned, or you mean as
Well, I've talked to Jeff before, and it's a spring, so it just flexes such that it can do that like 20-degree turn.
Yeah, absolutely. Yes, so it would trail by, if we turn the boat 20 degrees, the boom would track right with this 20. It would help push us along. It would help us turn. Is what I would
It's
say.
amazing to me that it's, even though you're pushing through, the saying, you can't push on a rope. I mean, you guys successfully did that.
With the thrust bearing on.
Well, yeah, not really though, because the attachment to the boat was solid. It wouldn't have worked if we didn't have the solid tube attached from the boat to the Kort nozzle. So it was, it was free roaming, from the stern of the boat to the bike, but all the force that was transmitted to the boat from the prop was through a solid shaft.
Yeah, it's through this
Okay.
black, I don't know if you see my mouse or not, but this black tube is all solid. And then we just had the flex drive running through it to the prop itself, which was mounted to it. So I think maybe
Stable.
this tube right here, the flex shaft runs right through that blue tube. You can see the orange, it has an orange lining up at the top, running along the side of the boat. So, and it would run down the middle of that tube to the prop itself.
You do have a thrust bearing down at the
We do.
right in front of the prop.
Yep, absolutely. Yep. We made actually we weren't sure how well everything would work. I don't know if I have pictures of it in here or not, but we actually made a cartridge which had the bearings for the shaft, for the propeller shaft, and we could swap that cartridge out. So if things got inside the bearings, or if there was a debris in there, or it got gummed up for whatever reason, we could actually remove that cartridge very easily, slap a new one in, slide the new drive shaft through it, and then reattach it to the flexible shaft. And yes, there was a thrust bearing in the front. And in fact, I think it was even a roller thrust bearing. It wasn't just a bronze washer, basically. So here it is in action. This is Jeff and I in Washington 360. I'm not going to show you the video just for the sake of time, but there's a YouTube video of Jeff actually doing it in his backyard. Things we liked about version 2, the upright tandem bicycle, strongly recommend it. I think Jeff would too. It is the fact that you have two. Let's see if I can show that picture. If you take a look at Jeff and I, our feet are actually 90 degrees out of phase. So when we're pedaling, you hear people talking about the pedaling motion on so many of these boats on the single manned props or pedal drives, and it's just murder on the knees. It's very frustrating just because there's no momentum. It's not like a normal bike. So what we did to counteract that by using a tandem drive is we put the pedals 90 degrees out of phase. So when I'm pushing down, Jeff is raising his foot up, and then he starts to push down, and I'm going through that weak spot in the pedaling motion. So the tandem drive, if you can get away with it, which on these big boats you can, it's a slam dunk. I'd be doing it without a doubt. We liked our gear ratio, big chain ring up front, 16 tooth in the back. I wouldn't go much smaller than 16 teeth in the back, just in order to keep that gear from getting too small. Because when you get down to 9 or 10 or 11 teeth on a gear, it causes a lot more friction. We put
Just real quick, Mike, if I could just add one more thing about the tandem, and that's that, I think one thing that really struck me is I was astounded at how much brain power you have to and how many iterations you go through just trying to figure this out. And the thing about the tandem is that it's just one component that's already been figured out. The structure works, it carries the weight, it has seats, has handlebars. So that's just one whole component and section of the puzzle that you don't have to really reinvent. So from that aspect, I thought it was really good.
It was awesome. Yes, because we had so much we were talking about. Bike cleats worked great. The Kort Nozzle worked great. The flexible shaft, it worked great, except for, and we'll talk about this in just a minute, the thing to watch out for it. The long boom attachment was great at keeping the propeller at the correct depth in the water. And the things that didn't work, which is probably more important, we have our flex drive, and this is version 2, and you can see down here this little orange segment, little open area here. You have this little orange segment, and then you have what's a shaft coupler right here, and in between is where our flexible drive is, that little black chunk right there. And the radius of curvature, the amount of bend that's supposed to occur in the flexible shaft was maybe, I don't know, was it 12 inches, Jeff? Something like that. I can't recall.
Yeah, it depends on the diameter of the shaft, but it is the way those shafts work is that they turn extremely easily when they're in a straight line. When they're slightly curved, it still turns really easily. And it has like a maximum curvature before you feel that you're actually physically getting resistance to bending. And at that point, it almost doesn't want to turn at all. So basically, the tighter the radius, the more friction loss you have, and the harder it is on the shaft.
So that little bend that we have right there, that's too tight of a bend is what it comes down to. And we were just maybe a day or two into Washington 360 and we broke our drive shaft, our flexible drive shaft. And we proceeded to break it, I don't know, two more times after that, I think, something like that.
Yeah, 3 times total.
Ultimately, it came totally unwound. We were talking about the fact that it's a spring, and it's not just a spring in that it moves like this, but it's a spring in that there's a torsion aspect to it. And so this was a 1/2-inch flexible drive shaft that we bought from like GI Industries. It's used for cleaning pipes. And it was just too small for the load that we were putting on it with the tandem drive. So we have this was the process I used to manufacture the duct. And when I originally did it, I created half the duct, the outside of the duct, and I created the inside of the duct, the shell, the skin of it. And then I put those two together and filled it. And in order to do that, I had to make it more of a nozzle shape, pretty tight. And so we took a look at that. These are the skins I made for it. Took a look at that and decided to use a different manufacturing process. Here is the cartridge we were talking about, and this is some of the corrosion that occurred. This is an aluminum cartridge, and then the ball bearings. These are some stop collars. There are some thrust bearings right there too. I'm not sure where they were at. This is the 16-tooth gear on the back, which ultimately froze up on us. And as Jeff was saying, trying to remove this nozzle out of the water was really, really extremely difficult. And of course, our butts just were so sore at the end of this thing. I mean, they were it was a rough, Washington, and there's Jonah. I love this picture, by the way.
He's in pain.
He's in pain. So things we modified. We sourced a different flexible shaft. They sell them on mudskipper.com. It's an 18 millimeter. They're economical. You can go to some of the people who actually manufacture these shafts, and you'll be paying thousands of dollars for an 8-foot long shaft. But these things worked great. We coupled together, I think, 3 of them. We made a new duct.
They are a little heavy. They're not light.
I don't know what you're going to do differently with that, though. I mean,
I'm just saying, yeah. It's a
trade-off.
trade-off.
Holes in them.
Yeah, it's a trade-off. Yeah. If we could shorten it and use less of them, that would probably be a benefit.
Yeah, we have to think about that. Yeah. You need a smaller prop if you do that. But anyway, we refashioned the transition that we talked about where we had too tight of a bend in the flexible drive shaft. We moved bike bearings a little bit to allow for a little bit better gearing in the back end of the bike. We allowed everybody to bring their own bike seats. So here's a new flexible shaft. It comes off of mudskipper.com. This is the difference in how pinchy the nozzle is. Everything to the left is on the inside of the Kort nozzle. So the old one is in red. The new one is that blue-black outline. And that's just a cross section of the Kort nozzle. So we have this airfoil shape. This is the process I used to make it. Basically used that airfoil shape and lined the skin, made an outer skin, lined it, then just put foam, got foam in there, and then sanded down to the new, the profile that I had put in these orange cross sections. This is our gearing for the back shaft. And this is this was our drive system. And basically it looks like our old one. Worked great for us. Not sure why I put that one in. Oh, there's the seat. Yep, everybody brought their own seat. This is the process we use to create our own propeller. So if anybody's interested in how to do this, they can email me and I'll let them know what I did. And this is ultimately the propeller that we carved. Didn't really intend it to look this good, honestly. I ordered a sheet of G10, cut it into 2-inch strips, laminated them all together, and started carving away. And this is the product that we ended up with. So really pretty. These are the different props that we had on hand. We didn't put all of our money into just the carved prop. We had the old props as well. We had fun making little hydrodynamic cones for the end of them, I guess. So
When you say
things of-
carved, what method did you use to carve it? Are you hand sanding it or grinding it or
so
machining
yeah,
it?
I used I have a handheld metal bandsaw. I mounted it in a vise, and I did my best to carve to certain guides that I had in place. And then after that, it was a matter of sanding, and it was a lot of sanding, honestly. Yeah, yeah. And in fact, I think Gator makes the sandpaper that's their extreme heavy duty stuff, which is the only stuff that would work. But yeah, ended up with a good product in the end. So things that worked, I think the Duck was more efficient. The car propeller provided more force at a lower RPM, which was kind of our goal. I think there's an argument to be had that reducing the RPM reduces friction on the drive system. So, you know, I think what we did determine is that it's hard to be objective because we don't have any objective data. But what we didn't do is get rid of it. We had other options available, and we ended up sticking with it. So the larger flex drive worked great. And yeah, and we all brought our own bike seats this time as well. So as opposed to having just to swap out, everybody could bring their own bike seat this time. And that worked okay.
Yeah, if you're a biker, you realize that, you know, you get used to one particular seat. And when you bike on another seat for an extended period of time, it hits you in all the wrong spots. You know, you're just not used to it.
So yeah, and I think the only remaining thing that I would really make it a point to modify, is this difficulty we have trying to remove the pedal drive from the water itself as we get moving. And we have some ideas regarding that, which are basically to create a linkage that would allow, you know, kind of like a backhoe, more or less. So that stiff piece that Jeff was talking about, pipe that runs down, that holds the nozzle in place and everything. If we create a linkage, there's a way to manage the radius of curvature on the flexible drive shaft and bring that thing up and out of the water. And it should work much better. So let's see. Oh yeah, and I'd consider carving a new. I think that there's a lot of research, there's a lot of unknowns. A lot of people think they know what they're talking about when it comes to these propellers, but I just don't think there's much data when it comes to props operating in the speed zones and with the loads that we're talking about. So it's a different problem than what you typically see prop information on regarding going high speeds or trying to go as fast as possible with low friction boats. So, and yeah, this is basically a synopsis of the stuff we just talked through.
Hey, Mike, we lost your sound.
Can you hear me now?
Can't hear you, Mike.
I don't think he's talking.
Can
Yeah,
anybody
can you
else hear me?
Yeah, I can hear you just fine. I don't know. Can you guys hear me?
Either.
Yeah. I don't know. That's weird.
Damn microphone.
I don't know why. No, I mean,
I can hear you just fine.
Can you?
I can hear you too.
Yeah, some people can. Is it just
No
the people
sound
in the room
problems
that
there.
cannot?
They can hear us.
Zoomers can hear each other, I guess.
Everything seems to be.
Can you hear us now?
Sure.
I don't know.
Stand by.
Seems to be working.
Yeah, they must
Microphone's
just
working.
be
Not the
the
speaker. So that means
connection.
You can
that's,
hear us?
that's working. They can hear us, yes.
We can hear you.
Mike's talking right now, but we can't hear him. Mark Dix can hear everyone. Don't do that.
I'll do this?
Don't do that.
Well, but we have no speakers right now.
Well, I
Okay, go
don't,
ahead. All right, we're doing it.
now we're back to echo.
If you can hear me, I'll ask a question. I'm
Go
wondering
for
what the history of each of the people on the crew, as far as what kind of a cyclist, they are coming into the project.
I'm an avid cyclist. We have another crew member who cycles quite a bit, and I think that's it. I don't think, Jeff, you did some cycling to prepare for this year, right?
I think I rode a bike in college and I hadn't ridden a bike since. And then I started commuting to work like 6 months before the race. So that was me. And then I'm pretty sure Jonah probably has ridden a total of maybe 10 miles prior to, doing the 360. So it was like half.
Just the things that we would advocate for in pedal drives, in particular on multi-hulls, I think it's safe to say. So yeah, if there's no other questions.
Mike, why
Yeah.
not the recumbent seating?
I hate a recumbent seat, and I know. So there's several answers. One of the ones, probably the best one, is the one that Jeff gave, which is that this is all set up and ready to go. You can get a tandem bike and you can get it going. It's hard to do a recumbent and do tandem at the same time. I'm not a fan of recumbent seating in particular because, the land speed record was set on a recumbent bike, but they are terrible at going uphill. And if you take a look at what you're doing in when you're out on the ocean, it's basically an endless uphill. The pressure that you have on those pedals, and so as a consequence, for me at least, I don't know, I have a nerve in my back or whatever. And people who ride recumbents, typically they're very worried about their seats, and they don't like people fiddling with them. And I think there's good reason for that. I think if you find it and it works, it's great, but it's tough to make it right. And when you got 4 people on a boat, it's just not a comfortable way to go. And you're not getting the leverage you want out of it. It's not the most efficient.
You also have to realize that Jonah and I didn't really have much to say about it because the 2 serious bikers on the team wanted the regular seats. So although Mike Hummels did try, he built 2 recumbent seats for our first version. We just, it just never stuck.
Yeah. I do think that your answer, Jeff, about the tandem and it's just ready to go is a great answer. And I also think that the idea of pedaling uphill you just have less ability on a recumbent seat to pedal uphill. And this is totally like pedaling uphill, just an endless uphill all the way to Alaska. So
I think there's another thing, Mike, that you were explaining to me that I think a lot of people don't understand, and maybe go into a little more depth on it. But it was when you're explaining to me why the single pedaler is so hard to do in water and why you get that dead spot. Like everybody always complains about the pedaling action is like chunky, like chunk, 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 chunk. And then you were telling me that you would explain it by saying, well, now grab the pedal by your hand and spin it. Maybe you can explain that a little bit, the difference.
Yeah, I mean, well, you're just, it's a biomechanics thing. I mean, your legs are set up for certain ranges of motion on a pedaling apparatus, and it is not convenient, to be trying to pedal through water. I will say, I mean, this actually what you're talking about reminds me of just the fact that I think that there is a solution for people who want to just put a single manned pedal drive. And Jeff and I talked about doing this. And he posted my analysis on Facebook. But it is to put a flywheel on there. I think if you put a flywheel on your pedal drive, you can operate it as a single person, and you can eliminate a lot of that irregular pedal stroke.
Yeah.
I think it's worth the wait. Absolutely. And in fact, if you have an issue with the weight, put a tire on there and fill it with water. And when you're done, dump the water out. But the idea is a sound one. And in fact, I think I told Jeff, if we don't do it, which we didn't, somebody's going to beat us to the idea. And we actually, somebody did it this year. Somebody did it in Race to Alaska.
And yeah, actually they had a twin single pedal drive set up where it was one person on each prop. And one they put a flywheel on, the other they did not. And when we passed them, because again, our system was superior, but they did comment that the one that they had with the flywheel was much easier, and it did keep that constant motion. It's just that, when Mike was showing me the difference here, he's like, well, grab the pedal, spin the pedal. So when you grab with your hand and you're making a rotational force, like you always would do with a hand crank, it's a smooth motion. You get on that same pedal with your feet and it's like extend and then nothing, extend, nothing, extend, nothing. So you just, like Mike said, it's extremely difficult to get that same kind of leading or pushing stroke in a consistent manner with your feet. And to the point, I think the team Sail Like a Girl actually tried to solve the issue by changing their props and going with a 3-bladed prop, because they thought that going with a 3-bladed prop was going to smooth that out a little bit. But that really wasn't the problem. It's just the single pedaler that's the problem.
Question in chat from Dennis. Where in the system would you put the flywheel? Maybe as the back wheel?
I'd put it in the trunk of the car and then leave it in the dock.
Jeff he doesn't want the wait. Like I said, I absolutely think it's worth the wait. And if you really want to get my analysis, it's posted on our website, on our Facebook page, Jeff. But it's all right there. Yes, and it talks about the rate of speed at which it needs to go.
Oh, great.
Flywheel goes, I would, the higher speed you have it going, the lighter weight it needs to be. So if you're willing to put the weight on, I would put it as part of the direct drive system. I think that the idea of your rear wheel being it, as long as you can drive your rear wheel and drive the shaft, that's a fine place for it to be.
I have a question about the internal gearbox losses. Do you remember was that a Nexus drive or a Shimano Alpine, or do you know what it was?
The Shimano 8-speed drive. There is a geared system, and I can't recall the name of it. It's 2 years ago now, but it supposedly it works. Yeah, it's like a 96% efficiency. So yeah, it's a 96% efficiency on that. There's an internal drive. It costs like $1,000. I wasn't willing to go there, but
You
No.
still have to end up making more. You're going to more smaller gears again, with a chain, and then
do.
you're changing directions again. So yeah, so there's some loss there still.
Yeah, I agree. I think the best option is just to go straight off the chain ring to the drive shaft.
So one thing I would like to say is that, the really cool thing about watching Mike go through this is that it's a incredible puzzle, because it's not just engineering, because there's costs involved, there's like shipping involved, although Mike doesn't seem to be too shy about shipping big things cross country, but big heavy things that eventually get cut out of the drive. But we won't talk about that. But there are all these other things that come into this, into this whole puzzle. And it's one thing to come up and draw something on a piece of paper, or even come up with an idea for it, but to actually get it, put together on the boat so it actually works and doesn't fall apart. That's it's a much bigger task than I ever would have thought it was going to be.
Well, and that's the thing, is that I'm talking about making this thing and the choices we made, but the reality is Jeff had to install this thing and I had nothing to do with that. So the idea of where the bike went and how the drive was connected to the boat, all of those kinds of things, Jeff is really the guru when it comes to all of that. So it is a tough problem. It is a really interesting. I kind of miss it. There's a lot we did.
You haven't. This is the first I've seen of the linkage design. You haven't sent me anything on the linkage design yet.
Yeah. Oh, I need to make it. I have did I? Oh, I did show you that, didn't I? Yeah.
The first thing I saw was the digger, which I'm familiar with because
So the diagram on the right is actually the proportions for the linkage that we need. So and now I just need to make a mock-up and see if you're willing to go there.
Yeah, because we can make that out of something really light, right?
I'm sure you could.
Yeah.
Yeah.
Here's an even lighter option. And that is, what about just putting a topping lift on right to the shroud? And you just
Drag.
lift.
Too much drag. We did have a topping lift on it, but we wanted to attach the topping lift where the tube came out of the water, so it wasn't dragging in the water. In reality, we didn't really have it in the right spot. It was still dragging a little bit. But when you drag a line through the water, it's quite a bit of friction. I mean, especially people who sail multi-hulls know that, like, if you're screaming, around at 15 knots and you lose like a screecher sheet overboard and you try and pull that thing back in, it takes a little bit of grunt.
We didn't hear your last sentence or two. So I was suggesting the topping lift, and you said too much drag. You'd attach it above the water, and then we didn't hear what you said.
Can you hear me now?
Yes.
Yeah, I was just saying that we did get it kind of wrong. We didn't pick the spot exactly right. So we still had a little bit of it in the water. But the whole idea was to keep that drag from happening. And I was saying that, if you sail multi-hulls and you sail at 15 knots, and if you've ever lost like a screecher sheet overboard and then you try and pull it back on board, it takes a little bit of, muscle to pull that in. That's all drag that's slowing you down. So we just, again, Mike designed this system that, his, mantra was to, maximize the efficiency. My mantra was weight. So we kind of combined that as best we could compromise. And then running something, it would be easier to pull up if it went further out and connected directly to the duct. But we just didn't want to have the drag.
The other thing I would say about the topping lift is as Jeff said, we actually had the topping lift attached, just not in the exactly right place for a good leverage. But there was actually times when we needed the topping lift. And yeah, I can't recall, maybe Jeff, I don't know if you remember those exact circumstances, but you know, we had double reefed or something. I don't know. I'm not sure why it would be reefed with the pedal drive in, but yeah, I don't know. I'm not sure. But
Yeah,
there were times where
the
there was a conflict between the topping lift and trying to get the pedal drive out.
yeah, the boom just wasn't in the right spot. Our topping lift went to the boom, and if the boom was off center or to the wrong side, then it just didn't really work very well to lift the nozzle out of the water because it just wasn't aligned, you know, in line with the nozzle. So so Mike is right, and we talked about putting a little extra boom in there, and I have to fess up, I nixed that because I didn't want to add any more weight. You know, I like the idea of just using something that was already there, and it didn't work very well. You know, I admit. So, you know, another compromise.
Yeah, I had a comment just to compare what Narwhal did compared to what you guys did. And it really is a big deal to build any kind of pedal drive and put it on a boat and make it work. I did the rowing stations on Narwhal, but it was Joel Smith that did the bikes. And he is an engineer. He ran a company, you know, designed and built recumbent bicycles. So he was way ahead in, you know, having all the components and the, you know, the thought process to put stuff like this together. So, you know, you guys should be really happy that you guys built one and put it on a boat too. So, congratulations.
Yeah, well, we learned a lot from what you guys gave us, and we're sorry. I'm still feel bad about what we gave you guys back.
Yeah,
after.
sorry it went back in pieces.
Yeah, we returned it ultimately, and it was yeah.
Yeah. So then, when Narwhal did Washington 360, Joel and I were not part of that team, but Dan Hill rebuilt the drives and you know, provided them for Washington 360.
Yeah, yeah. It's a fun project. It's there's a lot to learn. So and I don't think, obviously, people haven't figured it all out yet. There's still so much going on. Like I said, I think to me, the big issue is trying to drive these big, heavy boats with some of these props. It's just we don't have the technical data to go along with it. So people are searching, and there's some great ideas out there. It's pretty awesome to watch it.
There was a team, Pesto, that had a system similar to ours. His advantage was that it was extremely lightweight. He just had, you know, the shaft that came straight back, and that's it. He didn't have any kind of gimbal. You know, he didn't have any shroud. You know, no Kort Nozzle. You know, so when I look at that, the advantage of his was that it was very lightweight and simple. The disadvantage, I think, of Pesto's was that, number one, it didn't track with the boat. So every time that prop gets pulled up and down and swished through the water as the boat moves and the wave action happens, the prop loses efficiency. So it wasn't as efficient. It also didn't have the nozzle, so it wasn't as efficient. And he was also a single pedaler. So, you know, there's just no way for him to get the smooth, constant power that we could provide with the tandem bike. And then maybe the other system that I thought was a pretty good system during the last R2AK was Dragons, AKA Team Malalo. They used a tandem bike, so they had the same advantages of the smooth power that we had. I think they probably are better than us on simplicity because their system was pretty easy to deploy and it was all a very nice compact package. But I think they probably had some more loss and less efficiency than we did. They didn't have a nozzle. And also they were running it through gears, reduction gears and things like that. So probably a lot more losses for them. Unfortunately, that's the one boat that I don't really have a very good idea how we compared to under power because they were right on the edge of the dock. So when, you know, the gun went off, they got it way out ahead and we were buried all the way in the back. So by the time we got around the corner, the wind had already started to fill in and people were starting to sail. So really I would like to see their system compared to ours. Anyway, my thoughts.
Hey, Mike, Jess here. Alec has his hand up.
Yeah,
Go
Alec.
ahead.
Okay, yeah, great presentation. It kind of brings it all back for me, going through all the many facets of the engineering problem. I'd like to emphasize, in the end, it has to be reliable. So whatever you do, you have to make it really robust. Because once
You're the
it
man.
breaks-
Yes.
And robust, he was going to say and light.
and
Heavy.
light, and like one, well, actually the weight doesn't matter. So I mean, it's robust because once it breaks, you go from 0 to 0 real fast. Number two, having spares for the things that aren't supposed to break, that will break. So I know in Bad Kitty, I made spare propellers. Didn't need them, of course, because I made spare propellers. So of course you don't need them then. And we had 2 drives. So that's one way to get redundancy. If one breaks, you still got the other one.
Did Mike pay you to say that?
Yeah.
Well, we went through the same thought process, so we arrived at the same conclusions. Speed, you're going to spend a lot more time going at 2 knots than you are at 3 knots. So you really have to design it for your low end if you have to go any distance. So the large diameter propeller, the least loss possible. In our case, I designed it for one of our crew who I didn't want to have a heart attack. So
Sure.
we figured out how much we get out of him, which maybe 80 watts or 100 watts for an hour or two, and then everything we could possibly do, try to get that to the prop. So that was minimum. We had no gearing. We had like 2 bearings, 3 bearings, and kept it really simple. So
Yeah, I liked your system. Can you tell us a little bit about, because you guys had surface piercing.
yeah, well, this speaks to the bicycle thing, is that the human legs put out sinusoidal power. So a 2-bladed surface piercing propeller absorbs power sinusoidally. All you do is phase your leg stroke with the propeller half that's in the water. So when they're horizontal, above like both blades out of the water, you're at top dead center on your bike. You can't put any power out either. Everybody's happy. As the blade digs into the water, you're loading up, your legs are now getting some leverage and giving power. So I just simply worked backwards from the human body and figured out how can I match the propeller to that. When the propeller's underwater, both blades are continuously loaded, so it's absorbing power continuously. Your leg is still bringing out sinusoidally, so when you go top dead center, you slow down about, easily, whatever your slip is, plus some. We'll just say whatever your slip is. You slow down 40%. Well, that's horrible to go through that jerky motion continuously. And that's where a flywheel would come in. A flywheel would reduce that, perhaps greatly, but not completely. So it's a question of, how much do you want? A small flywheel would be a really good start. You would get rid of a lot of discomfort.
So just out of curiosity, because this is killing me. But so when I think of a flywheel, and it would be, because Mike and I hash this out back and forth all the time, and I'm not an engineer, I don't know anything, but I have messed around with flywheels, and to me it takes a lot of energy to get a flywheel up to speed, and then it seems to take a lot of energy just to keep that flywheel all on its own moving. So unless this thing is in space or in a vacuum, it seems to me that a flywheel would actually have more parasitic drag on the system than it would be effective in more effective than the alternative, which is to just do a tandem with the phase, out of phase with each, the pedals.
Well, a tandem's great if you got 2 crew that can pedal together. Don't have to even be equal. If one only puts out half the power of the other, they can still fill in that hole to a fair degree, and so instead of a sinusoidal output, you have two superimposed on each other, so you always have some power going to the prop. So see, on a bicycle, all the inertial mass of the rider and the bike is your flywheel.
That's exactly right.
And
Yes.
on your propeller, you've got a 12-ounce propeller on the end of the shaft or whatever, and you've got no inertia whatsoever there. So, and plus, water is 800 times as dense as air. It really, really wants to absorb power. So that's a conundrum. So you can look at things like a high-speed flywheel geared up, but every time you gear, you have a problem. Having a flywheel as part of your the rear axle of your bicycle, or where the chain goes to the drive, you already got the bearings there. You already got that stuff going on, so you wouldn't lose too much. But it's something to play with.
Yeah, I think to me, if I were to do 70-48 and I were going to do it solo, I would definitely have a flywheel on it, without a doubt. If I was going to pedal drive it, I think boogie barge, you know, every time they're doing it, they have multiple people, so they're okay. But yeah, if you're ever going to do a solo pedal drive, it should have a flywheel. And like I said, if you're an engineer and you like the technical side of it, you can see our whole analysis on our Facebook. It's Ruf Duck. Let's look up Ruf Duck on the website. Jeff posted it. You might have to scroll down a little bit, but it's all there. Yes. And,
Mike and I have, it's not an adversarial kind of relationship. It's mostly based on sarcasm and revenge, I think.
Yeah. No, I think, to me, the flywheel is as no-brainer as the Kort Nozzle is for low-speed applications. I think that they both kind of go into that. It's something that should be done. So,
Or a 1.5 meter diameter surface drive.
yeah.
Was Boogie Barge pedaling out of phase? Can you go back to the image of their boat?
Yeah.
I
hang on a
think
second.
they were, Mike. The picture will prove it, but I think they had every single one out of phase. Even they didn't just have 2 phases; they had 4 distinct.
Yeah, I'm going to guess that.
Yeah, you can see
Yeah,
it
see there it
there.
is. 4 distinct. Yeah.
I'm going to guess that everybody who pedals figures that one out in about 30 seconds.
Yeah.
It may take a bit longer to figure out they'll know what the problem is. It may take a little bit longer to figure out what the solution is, but most people get that one pretty quick.
I do think Boogie Barge is, these guys deserve so much credit. They're totally awesome. The guy that put that together, I do think it's a great example of trying to use a pedal drive and putting it on his boat, which he worked hard on. It's a cool boat, but I just don't think that the boat has the right characteristics to get him where he wants to be. He's going to have to change his boat structure.
That system, the drive system on the very back, the final drive part, that's very similar to what Dragon had, Team Malalo. It's just a simple compact unit with a right angle gear.
So that's a Mert Pack gear, which I think everybody knows about anymore. They're all using them. So yeah, and we could use that if you want. So.
Well, again, I mean, I have, since I'm not an engineer, I don't know the degrees, but I can definitely understand that, if you have something that's fixed to your boat like that, and you're out pedaling around in the, Dixon entrance or whatever, and you get wave action and, that's just dragging, your boat's just slopping up and down, that you are losing some efficiency. And I just love the way that our duck tracked. I mean, it was never more or never less than 6 inches below the water. And it just always seemed like it, tracked and it pushed, and, with no turbulence, no fuss. And it seems to me that when you go with a system like this, you lose that a little bit.
I love our drive. I really do. I think it worked great. The only downside right now is just getting it out of the water when it's time. That's it. And I think we can figure that out.
It's definitely one of the problems.
So have we got any more questions or are we done for the night?
How much drag did the flexible
Very
shafting?
interesting. Thanks a lot.
That was a great presentation. Thank you so much, Mike.
Yeah, Mike, check out the chat. There's some other thank yous from people in there that had to leave. And can we have your presentation?
I think Jeff actually has it already, but yeah, absolutely. Who should I just send it to Vince or?
Jeff, can you send it to me?
Yep, I can do that. No problem.
Great.
Anybody who
What are
wants
your
it,
plans?
go ahead.
Are you planning to do R2AK next year?
Does anyone want to contribute to this mainsail fund?
Fundraiser?
Yeah, I'll start baking cookies now.
Right. All right, I think we're gonna wrap it up. It's 11 o'clock for Mike Hummel, so thank you so much,
Oh,
Mike.
Yeah, thank you, Mike.
Alrighty. Yeah,
You the
no
man.
problem. My
All
pleasure.
right.
Yeah, we'll talk to you guys later. Thanks. Bye-bye.
Okay, bye.